All right, so this is going to be, as promised, the how to obtain the equation for part three. Remember, part three is CO2 versus temperature. We are not obtaining the equation the same way that we did in part one and part two. Okay, we're going to use the equations from part one and part two to go ahead and establish what this equation would be for part three. So in order to do this, we need to do some necessary pre-work. Okay, I decided to break up my paper into two columns. Right, we're going to need to do part one first and then part two. I'm going to do them simultaneously just so you can see what's taking place. All right, so first thing you want to do is go ahead and obtain your equations, the y equals mx plus b format equations from part one and part two. So here, the ones that I decided to use is CO2 equals 2.3x plus 1.7. For part two, I decided to use temperature equals 1.2x minus 0.8. Now, know that these are made up equations that I have on the screen. I am just doing this so you can see how to approach it. What I want you to do for yours is make sure, don't have a fraction here. If you do, go ahead and just divide it and go ahead and get a nice clean number. All right, nice clean number. It's going to make our life much easier. So if you take a look at these two equations, you'll see that they both have something in common, right? And that would be x. We have an x here and an x here. Remember that x represents years since 1959. All right, so in order to get rid of that x, we're going to do some arithmetic. We're going to go ahead and solve both equations for x. We're going to get x equals some number or some expression. So let's go ahead and start doing that. Remember, we have to use the reverse order of operations when we're dealing with solving linear equations. So first, for part one, I'm going to subtract 1.7 from both sides. For part two, I'm going to add 0.8 to both sides. And you'll see the next line is exactly that. We have CO2 minus 1.7 equals 2.3x. We have temperature plus 0.8 equals 1.2x. Okay, in order to get x by itself, we must here divide by 2.3. And on part twos, we need to divide by 1.2. So let's go ahead and do that. So what I end up getting is CO2 minus 1.7 all divided by 2.3 equals x. For part two, I get temperature plus 0.8 all divided by 1.2 equals x. Now, I'm going to go ahead and simplify this a little bit. Notice that CO2 and temperature here, right? If I was to add a constant before it, it would just be 1, okay? So it would be like 1 divided by 2.3 times CO2 minus 1.7 divided by 2.3 equals x. Same thing with part 2. 1 divided by 1.2, temperature, plus 0.8 divided by 1.2x. I do this because I just want to deal with decimals. I don't want fractions. I don't want to make our life any harder than it has to be. So let's go ahead and simplify a little bit here. So we're going to actually divide these fractions and just get one number. It's okay to round to 3 decimal points here. All right, so what I end up getting is two new equations where x equals for both sides. So for part 1, mine became 0.435 times CO2 minus 0.739 equals x. And for part 2, I get 0.833 temperature plus 0.667 equals x. These are the two equations that we're going to use to establish part 3's equation, line of best fit. Okay? Notice how both these equations equal x. They both equal the same thing. So that means that the 0.435 CO2 minus 0.739 has to equal 0.833 temperature plus 0.667. Let's go ahead and set those equal to each other. Okay, and you'll see that I did exactly that here. Okay, so I set these equal to each other because, well, they both equal x. They equal the same thing, right? So I just eliminated x here. The only variables I have here now are temperature and CO2, right? We're going to go ahead and convert this to a y equals mx plus b format. Well, if you take a look at your graph, you could see which one is going to be your y variable. Remember, that's the y-axis. Well, that is going to be my dependent variable, which is temperature, right? Because I'm saying that temperature depends on CO2. I can control the amount of CO2 I put out. I cannot control the temperature of the Earth, right? So I want to get something that looks like temperature equals some expression. I need to get temperature by itself. So let's go ahead and solve for temperature. Let's subtract 0.667 from both sides. And I did exactly that. I get 0.833 temperature equals 0.435 CO2 minus 1.406. Right? I obtained this by just doing negative 0.735 minus 0.667. That's what I end up getting. Okay. Now I must divide both sides by 0.833 in order to get temperature by itself. Right? So if I'm dividing one thing by 0.833, I must divide throughout the entire equation. Right? So I get temperature equals 0.435 divided by 0.833 CO2 minus 1.406 divided by 0.833. Again, let's make our life easier and just divide these two fractions. We're already dealing with decimals, so it makes sense just to use one single decimal instead of multiple ones included as a fraction. All right, so when I divide this, I end up getting 0.522. When I divide this, I end up getting 1.688. So my equation becomes temperature equals 0.522 times CO2 minus 1.688. Notice that this is in y equals mx plus b form. This is all you need for part 3. You do not need to do two different equations. You do not need point slope form. This is enough. Okay? So again, these are made up equations from part 1 into part 2, which means this is also made up. You're going to have to use whatever equations you have from part 1 and whatever equation you have from part 2. All right, I went ahead and did it myself, and I have approximate slopes and approximate y-intercepts that you should have for part from for part 3. Now again, it's approximate. Yours will be different depending on what equations you have from part 1 and part 2. However, it should still be close, or at least somewhat close, to what these values are. So the slope should be close to positive 0.01. Your approximate y-intercept, or your b value, should be approximately or close to negative 3. Now, if your values are not close to this, then we went wrong somewhere in the project, right? It could be part 1, it could be part 2, or it could just be an arithmetic error in part 3 or in this whole process, which is common. Okay, try again. Try doing the whole process again and seeing what happens. Remember, this is what you should be close to. If you are close to that, then fantastic, you did the right thing. If you are not, try again, or please send me your information so I can double check your work. Okay, this is going to be posted on my Severn, and I will send out an email letting you know that this has been uploaded. I hope this helps. If you have any questions, please email me. I know we have break. I know we'll be busy. However, I will have my email. I will have access to my computer all weekend long. Please, please, please email me so we can get these projects finished and perfected. Thank you.